affects rates of reaction is what's called a catalyst. Last year in biology, do you remember learning about enzymes? What do enzymes do?
They monitor reactions in the body.
Yeah, do you remember they talked about the lock and key? The lock and key, right? An enzyme has a particular shape to it. It's a biological molecule. And the things that need to react will come together and they'll fit on the enzyme. And because they're close to each other, what can they do? They can collide. So the enzyme is a biological catalyst. Without these enzymes, you and I would not be here. There wouldn't be life. Here is hydrogen peroxide. Now this is not your run-of-the-mill hydrogen peroxide. It's cheap stuff that you buy in the store. But it's more concentrated. I'll explain that later. Here's what's happening with hydrogen peroxide, H2O2. It breaks up, it decomposes into two things, water and oxygen. That's the reaction rate that we want to observe. Now, if I just take regular hydrogen peroxide and I set it in, let's say, a large graduated cylinder. I'm going to dump it in there. Oh, this is, by the way, 30%. And last period I did an unofficial scientific experiment to figure out what would happen if you drop some 30% hydrogen peroxide onto your skin. I now have 2 large welts, blisters. They felt like bee stings. I'm now getting over the pain. You can see some discoloration there. I spilled a whole bunch. And I quickly got my hands underneath, but not quick enough up there. This is really, really nasty stuff. 30%. The stuff you buy in the store is 3%. You're making me nervous, Borshine. You're laughing back there. Yeah, I know. And it splashes all over me. You gotta get it out. I'm gonna give you guys some extra. Let's finish off the bottle. I don't know. That's probably not a wise idea. How much do I have? I have double the amount that I should have.
Yeah.
Oh well. Okay, that's hydrogen. It looks like hydrogen peroxide in the bottle, right?
Yeah.
Why do you think that they put it in a brown bottle?
Because it decomposes under light.
Yeah, that's right. It doesn't take much energy. The activation energy required here is like, it's like a little bit. If I held this up, you can see it start to bubble right now a little bit, right? Just in ordinary life. If I held it up a little bit closer to the light, that would be enough energy, just a wee little bit, in order for this thing to start decomposing, for these molecules to collide with enough energy to break apart. So if you were in the store and you had clear bottles that you put this in, you would have, over time, what things? Hydrogen peroxide? No, you'd have water and what? Oxygen gas. Now that'd be an issue, especially if you have a closed bottle, right? You'd be walking down the aisle and then all of a sudden it explodes on you because of the gas pressure. That doesn't happen. And even if it did, it'd just be wet and oxygenated water. It'd just get you wet. You wouldn't have to worry about it. You can see the reaction rate right now is what? So are the hydrogen peroxide molecules, are they colliding with each other in there? Yeah, you betcha. They're just doing this. They're like, and they're just not getting over it. They don't have enough energy, right? So what we need to do is we need to speed up this reaction. What could I do?
Add a catalyst.
I could add a catalyst, of course. I could heat this up. I could put this under a burner, and then all of a sudden you see bubbles and froth and everything. I could increase the concentration of the hydrogen peroxide. I could add a catalyst. Okay, so let's do that. A catalyst, and we'll talk about this in just a moment, is like that enzyme. It brings the particles closer together. And what it does is it provides an alternative mechanism for the reaction to happen in. This is not the catalyst. This is just ordinary food coloring. Just to give it a little bit of color so you can see it better. Let's swirl that around. There we go. That's red hydrogen peroxide. It's bubbling a little bit. It sure isn't bubbling very much, though. I'm going to add some Ultra Original Albertsons brand. So put a little detergent in there. Okay, a lot of detergent in there. I think it's, you see how it's starting to get a little frothy there? Oxygen's being produced. We're just going to give this a moment to mix up really well. By the way, hydrogen peroxide, why do you use it? Clean wounds, right? There's 2 types of bacteria. There are bacteria that love air. They're called aerobic bacteria. stuff on the surface of your skin. And then there are the anaerobic bacteria. And those anaerobic bacteria, their metabolism, their chemical reactions that occur in their little bodies, their single-cell bodies, those produce off products which are toxic to you. And so we want to kill them. So if you have a big cut, you want to dump hydrogen peroxide on it. What does it immediately do? Frost and bubbles, because there's biological enzymes that break down hydrogen peroxide. Otherwise, hydrogen peroxide in your body kills it. So it's got to break it down really fast. What does it introduce in those deep crevices, those cuts? Oxygen gas. And what does it kill? The anaerobic bacteria. Also, it gets really hot. Have you ever noticed that before? It's a very exothermic reaction. And so the heat coupled with the oxygen gas releases and kills those. Move some stuff out of the way. Here's my catalyst. It's called sodium iodide. Notice how it has a brown color to it? It's just a solid little crystal. So I'm going to dump some of this in there. I should probably get a little bit more. More catalyst can't be bad. Well, I say that because you have about 25, 30 more milliliters than I should have of hydrogen peroxide. So here we go. Catalyst. You see the production of that gas there? See how that sped that up? Pretty sweet. The problem is that the reaction rate's still pretty slow, although that's building, isn't it? So let me do this. Let me just swirl it around a little bit. Oh, here it comes. And there it goes. It's really hot. Can you see the steam coming out of this bad boy? Stay on there. I don't want to touch it. Burn myself again.
Just grab it.
Yeah.
Yeah. Oh. So the soap is in there to show you that a lot of oxygen gas is being released, right? Whoa. How long goes? Too top heavy. What's all this brown stuff? What is that? Yeah, that's the sodium iodide. I wonder if I could somehow different than it's ever behaved. Sure. Oh, I don't have any more hydrogen. Ooh. Oh, wow. It's on me. Excuse me. Excuse me. That's enough. We probably shouldn't look at it. I'll give you an extra large chunk. Well, there's a lot of oxygen stored up in those bubbles, so I'm thinking since I have more oxygen in there, that'll increase the concentration of the reactants, right? So if this starts burning and I drop it in there, it should react at a faster rate.
Exactly, I know.
It should.
And this is why chemistry is my favorite class. Yep.
Okay, all right, here we go. Again, like I said, this might be the last thing I ever do. I don't think it'll explode on me. I don't have any gas in confined space, but it could burn brightly. I might go black. Jeez. Okay, I won't look at it. You shouldn't either. I'll turn off the lights though.
Oh.
Okay, here we go.
Remember, it goes like bright flash.
I'm going to ignite this and then I'm going to drop it in there. And we'll just see what happens. Again, if it starts burning, you don't want to look too right on it. Gets on fire. Whoa! Still burning down there. Oh no. Whoa.
Wow.
One more, down the center of the tube. All right. All right, here we go. Just kicks and giggles. Pick up the Bunsen burner so I can heat it over. Okay, I see what you're saying.
The last time you just dropped.
I just dropped, yeah. I'll have to apologize to the lunch ladies for that tray issue. Like this. I got you. I got you. Billy, you and I can go in business. Whoa! Oh,
That was so cool.
I've got this giant blue streak right down the center of my vision. Literally. Whoa.
It's just like everywhere.
That was cool.